Hello there, it's Matthew from Matthew North Music here, and if you're not a subscriber to this channel, please think about liking and subscribing this video and also hitting the little bell icon, and then that way you'll be notified of the next video that I post up on the channel. Anyway, today is all about this, and normally with these type of videos I won't show the finished thing until the end, but I thought, you know, I'll mix it up a bit today. Here we have two amplifiers and they look very similar, apart from that one has got my name written on it, Matthew, and that one says Marshall, but otherwise they look the same. Now why is this? Well, I can tell you it's because I built that, and I built it out of a kit from Modulus Electronics, the same people that I built the Fender Champ clone and the Fender Tweed Deluxe clone. Now I've always wanted to build a Marshall because Marshalls have always been my favourite amps. I love them to bits. They're just great. They're iconic. They're British. Yes, they are a complete clone of a Fender Tweed Bassman, but you know, everyone's got to start somewhere. But I thought, no, I'm going to get one of these. You know, midlife crisis, just turned 50. What am I going to do? I'm going to buy a shed and then I'm going to build a Marshall. So that's it finished. And we're going to start this video earlier in the week on Monday or Tuesday. I think it was Monday. And today's Saturday, so it's about a week's past, of me unboxing it, looking at all the components. And it's not a tutorial on how to build the amp, and it's not a video about, you know, me soldering every component. It's basically an overview of what you get and how I put the thing together and the ups and downs on the way of building it. So have a cup of coffee and hope you enjoy the rest of the video. Now, when you buy these as kits, the case normally comes after the actual amp bits arrive, because these have to be custom made, and it can take a while. I'm not quite sure. In fact, I'm going to have to open this at the end, I think. Here we go. Now, this is something that I think any guitar player will recognise. That is a small box Plexi style cabinet. It has the gold piping around it, and yeah, it looks and feels identical to my JTM 45, and it's got four bolts on the back, and then in this packet here we've got its feet. And like magic, here is the other box. Now this is the first box that arrived, and this will contain, hopefully, all of our parts that we need for this kit. And again, it was sent well packed, as all their stuff has been actually, because this is the third Modulus Electronics kit that I've built, or planning to build. We'll see how we get on with this. And inside we've got a piece of paper which should be a parts list. Yeah, this is the pick list, so this lists all the bits that I've ordered. And yeah, I ordered all the parts, and I got the more upgraded parts as well, like better potentiometers, etc. Because I thought, if I'm spending this amount of money, I may as well go all out. Okay. Now then, lots of stuff here, and we'll start with this. This is big and heavy, and this, I will guess, is going to be our power transformer. And this is a nice big chunky, it's a lot of weight to this, but you need to, you know, it's gonna do a lot of work. There's our power transformer. There's all our various cables that come out of it here. These are our primary windings, I think, and these are our secondaries, and we will have, this is our HT wires in red, these are our valve heater wires in green, then we've got, that's the centre tap, I think this is ground, And then we've got some wires on this side as well, I do believe. And I think there are primary windings. I'm not 100% sure which is which because they're but I'm pretty sure that's it, because unlike a Fender amp, this amp, or the Fender amps that I've built rather, this amp actually has solid state rectification. So there isn't a separate set of heater wires for the rectifier, which is what I was kind of looking for. So anyway, I think we have to pair up a couple of these for the primaries. I'm not sure, but we will get round to that when we start building. So that's our power transformer. We have another heavy lump of stuff here, which I'm pretty sure is going to be our output transformer, because that's usually the second biggest transformer in the kit. Yep, this is our output transformer. This will take a high impedance, high voltage input signal, and that outputs as a low impedance, high current signal to drive the loudspeakers. So again, nice big solid transformer. Just pop that to one side as well. And then we go to this. And this is a smaller lump. And this is going to be our choke for the power supply. It's just got 2 wires on it, I think. And this sits across one of the smoothing capacitors, I think. We've got lots of other bits and pieces here. This feels very delicate, so I'm going to be very careful taking this apart here. Just a little bit of sellotape here, because I think this is our Plexi panel. Yeah. So we have 2 panels here, the front and the rear. That's our rear panel, that's our front panel. And in here we have got our tag board for the actual amplifiers guts, if you like. This is where most of the business goes on for the amp. So a good old-fashioned tag board. I mean, that could have been made in the 60s. And it's had all the eyelets in the right place. And yeah, this will be wired up, and then there'll be some spacers somewhere here just to hold it in place and keep all of that away from the chassis, because obviously you've got very high voltages running on this. We now have this, and how's the camera doing? Let me just tilt that down slightly so we've got a bit more room in front. And here we have our chassis and hopefully all our components inside as well. So I'm just going to take this off very gently. We'll look at the chassis at the end. We'll take out what's inside first. So there we have all our components here, and we've got our valves. So we've got our output EL34s, classic Marshall output valves. We've got 3 ECC 83s. There are preamp valves and phase splitters. And now we've got all the other bits and bobs. Here we've got our AC input, some heat shrink tubing, and our earth wire. So that's our mains input there taken care of. We've got bags of wires for various connections on the amplifier that will tally up with the colour coding that is on the circuit diagram, or the layout diagram I should say. Right, these are all our capacitors. Got our big smoothing caps here. We've got our signal caps. We've got, as you can see in there, we've got our diodes for rectification, and all our resistors are there as well, and they've all been bagged up in values. And I always check the colour codes, and I sometimes even just stick them across a meter as well, just so I don't make any mistakes. And here is all our final bits and bobs. In fact, before I open that bag, I'll just show you the chassis. So this is our chassis for the amp. Nice and solid and heavy. We'll have our power transformer there, our output transformer will probably go here, our choke will go here. We've got some capacitors here, then we have our 2 output valves there, our preamp valves here. That's our back of our chassis, so that'll be the that's where our selector switch for our impedance goes, mains input there, etc, etc. And then there's the front, so we've got our jack sockets there, our controls here, and our power switches here, and our colour light there. So this is nice and heavy, nice and solid, with M6 bolts there, which will then, in fact these are exactly the same as cage nuts that you'd have on 19-inch racking. And so there's a little bit of play there, so it means when it slots in, you can jiggle a little bit to get the bolt in place. But yeah, nice good solid chassis. And then we'll have our nice Plexi display in front of that. In this bag here then is all of our other components. And there's our valve covers for the preamp valves there. There's our light indicator. We then have our Marshall style knobs. We've got various nuts and bolts here for things like earth tags for the earthing, and also for holding the valve bases to the chassis. There's our transformer nuts and bolts. We have these are the fixings for the two capacitors. There's our standoffs for the board. They look like they're M2.5 or M3. And these are valve socket nuts and bolts there. These are our two on-off switches. One's for the HT and the other is for the mains coming in, although they are the same connector. Here's our impedance selector controller. These are our input sockets. These are proper old school connectors. These are exactly the same connectors with the recessy bits here that were on the GP Electronics amplifiers that Jerry used to build. They're on the front, and then these more standard ones with the plastic washer thingies. They'll be for the speakers on the back, because you don't really look at that. These are our valve bases. Nice good quality valve bases. Nice big thick metal there. Yeah, they're nicely made. They're good quality. These are our pots. Now I ordered the I think these are CTS pots, because I just wanted, the best quality I could get. Because the thing is with things like your volume pots, you don't want to be after a few years turning it and going because carbon's built up and they're just not very good. I mean, that happens anyway, but I kind of think if you've got larger pots with more travel on them, then you're going to get more. It's going to be more accurate as well. So there's our pots. These are some grommets that will go in the chassis for the transformers and the choke. The two big ones for the output, and the mains transformer, the little one for the choke. And that's just so the cables don't rub against metal, because we don't want that. That looks like a back panel, blanking panel for something. Not sure what actually. That's all our parts then laid out. I have one other part that I also have for this kit, which I'm going to show you right at the end. You can probably guess what it is. But that's it. That's all the parts for the Marshall kit, or the clone of a Marshall. And I'm going to start putting it together now. And the first thing I will do is I will mount everything that goes on here. So all the valve bases, the transformers, all the heavy stuff will be mounted first. The next thing I will do then is I will mount all the pots, sockets on the front and the back, and then we can start wiring these things up together. But for now, that's the kit. If you look there, you can see some of the standoffs for the circuit board that will be fitting. Right there, you can see an empty hole where there was a standoff fitted, but I unfortunately over tightened it and snapped. So here is a cautionary tale: do not over tighten standoffs. However, if we look at the top of the amp, it's starting to look a little bit like an amplifier. I've got the 3 transformers in place, I've got the 2 main filter caps in place, and I've got our valve bases all screwed in and orientated in the correct way to match up with the layout diagram. Now you could say a mistake or a mishap, but not really. I just forgotten to put the bases for the valve covers for the preamp valves on. But 5-minute job, and they're all back in place where they should be. I'm starting to make some headway with this build now, and I've got almost half the circuit board done, and it's not looking too bad. Unfortunately, the kit was missing a couple of resistors, which was more than annoying. So I've actually just ordered some because I figured they'd turn up quicker than if I contacted the company and waited for a while. However, there was one other little annoyance, and that is one of the volume pots is broken, and I can't prove it was me who broke it or it was broken in transit, but when I took it out of the packet it was like this, so I'm going to have to buy another one of these as well. This is day 2 of the build, and the first thing I'm going to show you is the main circuit board. You can see that the way this is designed is pretty much identical to an original Marshall if you've ever seen one. The ends of each component go in the holes here and then they're soldered in as so, and the wires come up through the board and they're wrapped around the bottom of the pin. And this is actually a really efficient way of making a circuit board, because you can put the components in place and you can feel that they're fairly mechanically stable, and then you put the solder in to keep it nice and solid. If we go to this end of the board, you can see there are some components where they've had to be tagged onto another. This is a little bit untidy. I'm not 100% happy with this, but it's how we've had to do it. And so the resistors have shorter legs, so I've wrapped the resistor around the capacitor rather than the other way around, which you see some people do purely because the resistor legs aren't that long. Now, talking of these sort of old style resistors, I have found, because I've measured every component before I've soldered it in, that the tolerances can be up to sort of 10% out on some of the values of these. I mean, even these resistors here, they're all exactly the same, but they all measure slightly differently. So I'm not, personally, I'd rather have brand new modern components than these sort of older style parts. But that's kind of what came with the kit, so I've just gone with it. But I'll just show you with the multimeter. If we say, look here, that resistor saying 68.5k. This resistor is saying 67.5k. We go to these two, that's 66.6. Yep. And this one is 70.4. Now these are all supposed to be 68k, and that's quite a difference in value. They should all be roughly the same. So I am tempted that I may well do a revision on this kit, depending on how it turns out. And if it's not performing as well as it should be, I'm going to actually replace all these with modern components. Well, just look at these here, for example. That's saying it's 101k. These are supposed to be 100k, and that's 98.6. Well, that's 3k difference. That's quite a bit, really. And saying all the rest of the resistors are similar. None of them are within tolerance of modern day components. If we look at the flip of the board, then there's wires everywhere because these are all going to all the different components, the controls, the sockets, etc. But we have got these little link wires here. There's one there, there's some ground wires here, and I've tried to keep them out the way of any of the other components. And there's some here as well, and I think they look pretty neat and tidy, and hopefully they're not going to have any problems. The standoffs in the cabinet themselves are actually 1 centimetre, so this is going to be a good distance above the actual chassis, so we're not going to have any problems with cables getting stuck or indeed any short circuits. Anyway, well, let's have a look at the chassis next. The chassis is upside down at the moment. This was a bit of a problem, this indicator fitting, because it wouldn't actually fit through the perspex of the chassis, of the plastic here. So what I ended up having to do was, using my cone cut tool, I gently turned it and then went round the edge of it with a deburring tool just to make the hole in the plastic slightly bigger. But now it fits. I mean, these aren't great, these lights, because they do actually move around a little bit, but again, that's of the time, and that's kind of how they did it. In this end of the chassis, there's not too much going on. I have installed the jack sockets. They're earthed here and here. There's a 1 meg resistor across here, and the earthing there has been taken to chassis. The rest of the wiring will come in when the circuit board's in. Most of the chassis work today has been at this side of the chassis. The first thing I do is get all the mains in. So we've got our main socket here, that's hooking into the fuse. We always use the bottom of the fuse socket so that if the fuse pops out, there's no chance of getting electrocuted. Well, some people put the mains in there, and you can get your finger in there sometimes and get a belt off it. I mean, you shouldn't poke your finger in anyway, but you know, safety first. So the mains comes in there, it comes up here, and it goes up to the main switch here. Again, that's all heat shrunk, and then it comes into the primary of the transformer. Then the negative of the transformer comes out and it ends up going here. So that's the loop for the mains. The HT is slightly different to how I imagined it would be, and the design is that you get the rectified HT will go into that fuse, that then goes through the fuse up to the HT switch, and the HT switch comes back down and it feeds the first of the stage of the filter capacitor, which is here. And there's also a line that goes off to the choke and to the output transformer, because the output transformer puts DC through the coils onto the main inputs of the DC part of the output valve, as well as the AC component then going through the transformer to come out to the speaker. Here's the output of the output transformer, and if I turn the camera down a little bit, you can see it's going into the switch here, which is the impedance selector. There's a couple of other bits got to be connected, and I did take out the speaker jack sockets just so it gives me more room to get to the valves and all the various other bits and bobs I need to do. The input of the output transformer is here, and as I say, that comes down here. I put some heat shrink around it just to keep the leads separate. That's fed from two sides of the output valves, but it also puts DC on as well, so it's quite a clever thing really. And then there's another wire that goes over to here. I've then run in some of the heater power. I've done what Modulus suggest, which is instead of twisting the wires, they actually are in parallel. So it comes out here in parallel down the bottom. It feeds the first output transformer, but then also it's feeding another pair of wires that go up to power the light. So it does two functions. This then is in parallel to the next output transformer, output valve. And then what I'm going to do is I'm going to do again as it was suggested with the layout, and that is I'm going to keep the heater wires in parallel, so you know they'll look like that with heat shrink like here, and then they'll sort of come up here and they'll sort of stick out and come along here and go down and so on. And the idea is that you're keeping the valve heater wires away from any signal. Now I don't know how practical that will be because we have got other stuff here, so I'm gonna think about that tomorrow. But other than that, that's as far as I've got tonight. But I think I've broken the lion's share of the work now on this amplifier. I don't think I'm going to have it ready to take to the blues jam tomorrow night, but that was never going to happen really. But we can kind of get an idea what it will look like when it's finished, because once the circuit board's in, it's going to be about there, and then everything will be wired up, and then I will have hopefully a fully working 50-watt Plexi. It's the next day, and if we look down here, I've added these resistors here and put that link wire in, and these are 1 ohm resistors. Now the idea with this is when you do the bias of the amp, you can actually just put your test probe on there and you can measure the voltage across it, which of course, because it's 1 ohm, the milliamps, the voltage will be the current limit. So that's quite a good way of testing the bias, especially if you don't have a like a valve base with breakout wires to go to a multimeter. On this side, you probably can't see it too well. Let's move those wires back, but I've put this ground bus in here, and this is going across the negative side of the capacitors. The two center taps out of the transformer are soldered to there, as is this earth wire. There's another earth wire coming down here from the presence control. And here in the preamp valves, there's a link here. I've put in a link here, as well as a resistor going across there. So I've just popped all those in. And also I've got a just ground bus here, and I'm going to put in some other wire as well like that. It's actually heavy duty wire from mains cable, like this, and it's great for doing ground buses. It's nice and thick, nice and solid. Here's another little trick then. So I want to put a link between these two pins here. So I've actually just bent them up, and then if I bend the end here of a bit of copper wire, I can kind of measure the distance between the two. So the bend we're going to need is going to be about there. So if I then do that, and I bend the wire, and I can then just check it, and that looks about right. So I'll now snip it off. I can then place this, and then I'll just get my side cutters, and I'll just cut off some of the excess on this side. And the other side's not too bad. And that's nice and solid now. It was nice and hot too. And it just looks neater. I mean, you know, you can just run wire across, but I just think that looks neater and tidier. I know it's a funny angle, but I had to use some slightly thinner wire because this thick stuff wouldn't thread through the jack sockets. But our jack sockets are now connected together for the output. This is the negative side of the output transformer that's going to the negative of the speaker. There's also a wire coming here from the presence control that has to be grounded at that point. This is our output signal, and that's going to the middle of the rotary selector for the impedance of the amp. So all of that is now wired in. The next thing then is possibly one of the trickiest things to do in the entire build, and that is to get the circuit board in place in the amplifier. Now there's a lot of wires here, but fortunately there's enough space that they should all fit, but you just got to kind of juggle it in, I suppose, to kind of get it in place, and then you need to start wiring things up. Now the idea is, I'll turn it up the right way might help. Now the idea is I'll get everything at the bottom wired in first. That's basically all the valves and other connections, and then I will wire up the pots afterwards. So it's kind of, the wires are facing roughly the right direction, but let's just pop it in and see if it will get into its mounting slots. Again, there's wires sort of dangling here, there, and everywhere, and going to check, yes, that's the bottom one. This is the top one going to that resistor. I'm just going to thread that under there to remind me. And I think we might get this in place. Now, it may seem daft, but these wires are going under the board, and you might just want to double check where they're going. And how do you know where your wires are? Well, just use your continuity tester on your multimeter. Get your continuity tester, put them together, they beep. So this wire here is going to be one of these two. It's not that one, but it is that one, and that's the correct wire. So I'm going to continuity test every single wire as I solder them in, because that way I know I've got the right wire going to the right pin. Because I can't emphasize enough with any amp build, particularly any valve amp build, that you get one thing wrong, at best you'll blow the place up, you'll blow your amp up, at worst you might die. That's the bottom line with amps, is the voltages are so high, you have got to make sure safety first. So check, check and check again. This is Bob Dylan, the Bootleg Series, Volume 1 to 3. And it's taken me the duration of the first 2 discs to get to where I am at the moment. And as you might notice, I have now got everything on the bottom half of the amp finished. That's the preamp valves, apart from the heaters, which I'm going to wire in at the end, as I mentioned before. All of the power supply here is now all wired in. Our 2 capacitors here, the EHT coming from the secondary of the power transformers going through the rectifier is then feeding this smoothing capacitor here, and everything else goes around into the system. Although they're saying that's coming out of here, it's actually going into this fuse and then through the switch and then back, and it's kind of split off this resistor here. So everything there is now complete. The next thing to do is to wire the top up, or as much as I can, because obviously I don't have this pot here, the one for the, what was it, the treble, because as I said, the original one was damaged. But once I've got that, I can wire it in. But everything else I can now wire in, and some other bits and pieces I've wired in, like the ground off here. I've got a ground to go there from somewhere on here, wire the jack sockets in. And then I've just got to wait for the parts, and then we can test. Well, after that Bob Dylan CD, I'm almost finished. Now, this is the front of the amp, as you can see. And you remember in the packaging, there was this thing, this blanking panel. And I was trying to work out what it was for. Well, I've worked out what it is, or rather I looked it up on another website. If I turn the amp round, you see here, we've got two filter capacitors. Well, what you could do with this amp is you could take them out or move them around, and you could have a valve rectifier in here, like a GZ34 or something, or you could juggle things around, and it was to put in. If I just tip it up, I can show you on the inside. You could mount one of these capacitors here on the side there, and I think that's for JTM45 wiring, and then you could get this blank panel here and you could cover over one of the holes. Although I can't quite work out why. Oh, it's because these filter caps aren't used in the JTM45. The filter caps for JTM45 are actually on the circuit board. So you'd only need, you'd take these both out, you'd have your valve rectifier probably here, and then you blank the other panel, and then you'd have a filter cap inside, which would be mounted, as I say, just in here because there's two holes. So that's what it's for. But if we have a look at the actual amp, I'm going to turn it round. You may have noticed that this capacitor's loose. That's because I haven't soldered it in that side, because we've got this I can't remember off the top of my head. I think it's a 10k resistor that's got to go there, and there's another one that's got to go there, so I've not soldered that in. And if we look at the volume controls and tone controls and things, these three wires here will eventually go here for the what was it, the treble control, and there's a jumper's got to go across here as well from here. And once that's done, I can then power it up, do some voltage checks, and then I'll pop the valves in, quickly check the bias. So you've got a bias trim pot there, and then we'll see what the amp sounds like. Okay, one last thing that I didn't do, which I completely forgot about actually, which I've just done now, is the heater wires for the preamp valves. Now, what I've done is I've kind of traditionally routed it from the second output valve into the first preamp valve, but then I've done what's on they've done on their website actually, and I've brought the wires up vertically and across, down, up and across. And that's because these two valves, particularly this one, this is where the first stage of gain is. So this, if you're going to pick up hum and noise, you're going to get it here more than anywhere else, because it's the signals at the lowest level. And so by doing this, we're keeping the heater wires well away from the valve, and because we're running them all in parallel like this, that seems to be regarded as a better way of keeping the noise away than actually twisting them, having them twisted, because normally you'd have them twisted and laying against the edge here. However, this, it's physically moving the wires further away because they're not going to be going over these signal wires here. So with a bit of luck, that should actually give us a quieter sounding amp than even an original done in the traditional way, but we shall see. I went round the whole board doing some continuity tests, particularly grounding issues, to make sure all the ground wires were working as they should be, and most of it was. However, I did notice that I'd actually forgotten to install one of the ground wires, and it was this one here. And you can see that black ground wire that's coming off the pot for bias, and I'd forgotten to wire that in. And as I was going through the layout diagram, I thought, oh, that wire's not in. So I unscrewed the board and I took the board out, and as it turns out, this board comes out and there's plenty of wriggle room underneath by having the wires like this, so you can actually lift the board up if you need to. And yeah, that worked very well. So actually, if you did need to take the board out for any maintenance, you could probably get as much access as you need without having to disconnect all the pots. But you know, if you had to remove all the pots, it's, you know, it's 6 knobs and 6 nuts, and then everything comes free. The only thing that's wide and a bit tighter, I suppose, is here is the HT supply, but that's only a cable tie that I've put in just to neaten things up. But yeah, everything else seems okay, so I've just got to wait on those parts and then I can plug him in. Well, finally, I've had some bits and bobs through the post. I've had some 10k resistors and I've had a pot. Now, this isn't exactly the same type that's in the amp already. It's because it doesn't have the solid shaft. It's a split shaft pot, but it'll do for now, and I'll probably see if I can get the people that made the kit to maybe replace it, and I'll pop the other one in, but that should do for now anyway. Okay, well, the amp is built. I haven't plugged any of the valves in yet, but what I have done is I've got my voltmeter hooked up, which you can't see at the moment, but the idea is I'm going to make sure it's switched off, which it is, and the mains is off on the panel. I'm going to plug it in, and the first thing I'm going to do is just switch the power onto the chassis, and nothing's gone bang, and that's good. I'm now going to turn the mains power on, and I'm just going to flick the switch and see what happens. And the lights come on for the power. I don't, you can probably see that, and that's good. And I'm now looking at the HT. Yeah, 479 with the HT switch on. So yeah, I think that's kind of working now. So the voltages seem okay. So what I'm going to do now is I'm going to turn the amp off, I'm going to pop the valves in, I'm going to plug it into a speaker and see what happens. Well, I've got my valves here that go in the amp. Now, our output valves are JJ EL84s, and they're a matched pair. Now, some people are a little bit, you know, sniffy about JJ valves, and they say, ooh, it's not as good as, you know, Solvtex or, you know, other brands, but I found JJs to be always pretty decent. And at the end of the day, it's just a component. Now, always be careful, and I'm teaching granny to suck eggs, but lining up valves into the valve base correctly, because it is possible to ram a valve into the slot and it will be in the wrong angle. And what you don't want to do is to push it in the wrong hole, because at best you'll break the pin off, which is really annoying, because then you've got to be super duper accurate in putting the valve into place. Or at worst, you completely break the valve. And if you physically break one valve, then the chances are the other valve's not going to be much use, because it's not going to be matched to the valve that you've put in. Okay, all of our valves are in, and I'm just going to find a guitar lead, and then we'll plug it in and we'll see if this thing works. Okay then, the moment of truth. I'm going to switch the mains power on, and I'm going to switch it on remotely, because if there is anything wrong with this and it goes pop, I'm at suitable distance away. But and then switch it on. Right then, nothing's gone bang. The power valves are all heating up. You should be able to see that lovely beautiful glow of the output valves. And then if I move the camera here, yep, the input valves are all glowing as well. So I am confident that so far everything looks good. So the next thing to do is to hit the on button. And it does, it's making that horrible noise. And that to me is probably, I've got to check the wiring, but I would guess that's the something to do with the way the output transformer has been wired in. So I'm going to unplug, turn off, unplug, and we're going to just check everything again. Okay then, I spoke to Modulus and they told me to make an adjustment on the circuit, basically reversing the output transformer wiring, which I've just done. And so now I'm going to switch it on. Hopefully the battery isn't going to go flat on my camcorder as I do this, but the volumes are turned down. Let's switch the amp on and see what happens. And so far, no horrible squeal. And gentle hum that you would expect from an amp. Well then, I just did a test and the battery then went flat on the camera, so I'm hoping it might have caught that. If not, this is me reenacting the test. And just to catch up, what I had to do was swap round the output transformer, basically reverse the polarity. And I've actually had that fault before on another amp where I changed an output transformer. I got the wires the wrong way around and it made that horrible farty noise. Anyway, let's switch the amp on. And it works. I'm going to try the other input as well. That's very trebly. But that's why it's called the high treble input. Now you can see on my current meter it's saying it's 32 milliamps of bias current, which is roughly where it needs to be. I think 35 is kind of thought of as the optimum. So I'm going to adjust that. And then I've got to do a job I'm not looking forward to, which is drilling the cabinet. Well then, that's our finished Plexi there, all in its glory in its cabinet, and it looks the business and it sounds the business, but there's just one thing more that I need to do. And there we go, I think that looks better. As a test then, I'm going to compare the amp that I've built with my JTM45. Now, there are a couple of variations that we're going to get, obviously. The two cabs are not the same. They both have Celestians in, but that has greenbacks in, that has G12s of another type. But it's not about the finer detail, it's more about, has the amp that I've built do what it's supposed to do? Does it sound like a Marshall? Now, you might be able to hear, there's a little bit of hum coming off this amp. Not a huge amount, just a little tiny bit. And it's comparable to the old Plexis that I've owned in the past. They all had that similar kind of, 100 hertz hum, but very, very low level. And, even if you're practicing, you're not really going to notice it. But, it is there. It isn't there with the JTM45 Mark II, but then this album's had years of refinements, is that a word? It's been refined over the years. They built it on a PCB to keep the noise down. They've obviously modified certain components and things, whereas this is built to the same spec that an original one was built in the 60s. And certainly you never hear an old Cream album or a Hendrix album without any buzz coming from the guitars and amps. So I'm going to turn the level up a little bit. I'm almost at 2, and this is just to give you an idea of the clean tone. And I can tell you now, that is really loud. I'm going to move the mic over to here and I'm going to plug into the JTM45. And I'm going to turn that up to 2. And this is how the JTM45 sounds. So sounds a little bit cleaner, but then I'm playing through greenbacks, so the speakers are different. I think these speakers break up a bit more. But what you really want to know is, does this have the kind of, you know, the Marshall edge? By the way, all the EQ is left in the middle. And if I'm going to turn the level of the mic recording the amp down a little bit, because it's going to overdrive it. Move that to roughly where that was. I'm just going to turn it up to 4, and so this is it with a bit of drive. And that's all you're going to get, because I don't want to disturb all the neighbours. But you know, that's proper Marshall rock tone. And if I do the same thing with the other amp, and I stick that up to about 4, and this is how it sounds. And yeah, to me, they both sound pretty much as you would expect. They sound like Marshalls, they crank like Marshalls, they distort in roughly the same place. And so I think this is a really great kit, because it does exactly what it says on the tin, apart from the fact it says Matthew, obviously. It is a great sounding Marshall amp. It's got the character of a Marshall, it's got the look at, and you know, if you want something that sounds like a 50-year-old amp with new components, then that's it. That's exactly what it is. And that's the same with all these other kit amps that I've built. They all use the original circuit diagrams, pretty much the original layouts, and what you get to create is an original sounding amp. So yeah, really pleased with it. Anyway, if you're interested in these type of things, I've got some videos of some other amps up on my channel. But for now, thanks for watching, and don't forget to like and subscribe and hit the bell icon to be notified even of new videos. So I'll catch you on the next one.